Okay, since we went from the bottom to the top, I think, did all of us get through number 2? I think for mostly, okay. And I know some of us got to number 1, or we got to number 1. I don't know if we didn't all get through it, but let's just work through this together. So one of the two in number 1 is a U sub, and one of them is not. Now this one, when you look for what you're going to use for U, we usually look for what's inside the parentheses. If we look for the inside the parentheses on this one right here, we could use that, but then when we take the derivative, we're not going to get this part, so we can tell that that's not going to help us any, right? So instead we go over here, and we could make our U into 4x plus 1. So that means du is equal to 4 dx. We agree with that? So that means in here, we would need to multiply by 4, so outside we need 1/4. We all agree with that? Okay. So then that means I'm going to have 1/4 times the integral of u squared du. Okay, don't forget your du's and dx's on things. So then when I take this integral, I'm still going to have the 1/4. I'm going to add 1 to the exponent, and then I divide by my new exponent. And then I have to put it plus c. So then that's going to give me 1/12 times 4x plus 1 cubed plus c. We agree with that? Yes, absolutely. You could also put it over 12, and that's totally fine. Everybody good with that? Yes? Okay, so on the left, since we don't have a u, we know the u part's not going to work, we need some other way to be able to go about this. Now, if it was like 3a, then we could split that into 4 different integrals. Even if you don't write it like that, you can just do it individually. That works because this is addition. This is multiplication, and we do not have a product rule. Therefore, we need to multiply it out. Okay, so when we multiply it out, it's going to give me the integral. I'm going to leave that x plus 1. And then 4x plus 1 squared is not 16x squared plus 1, right? We know that much. So this is going to be, it is going to give me 16x squared, but then I'm going to have plus 8x plus 1 dx. Okay. Then I can multiply all that out, and let me distribute the x. So this is going to give me 16x cubed plus 8x squared plus x. Then I can distribute the 1 and get plus 16x squared plus 8x plus 1, and then dx. Then I can clean that up and get 16x cubed plus 24x squared plus 9x plus 1 dx. Do y'all agree with that? And then I'm going to integrate. I'm going to write it down in here because I don't have any more room. So this is coming down here. I'm going to add 1, so this will give me 16 times x to the 4th over 4. If you wanted to take care of that all at once and put a 4 there, that's fine. I think it's a little safer to kind of step yourself through it so you don't do anything weird. Plus 24x cubed over 3 plus 9x squared over 2 plus, what does this integrate to? X. That seems something that kind of stumped all of y'all at some point yesterday. Plus c. So really in the end, I get 4x to the 4th plus 8x cubed plus 9 halves x squared plus x plus c. Everybody okay with that one? Any questions? All right, so let's talk about which ones of these, because you have these done already, which one of these were U substitutions? So we know 1B was, which one on number 2? 2B, right? Which one on 3? 3B. They weren't all B's, were they? They might have been. Were they? 4B. Oh, no. And then 5A. Okay, so notice where you found your U's from. Both of these are in the denominator, but it came from the denominator because this was easily rewritten as something in the numerator. Make sense? Here, they were both under the square root, but one of them was more than one term under the square root. Here, and I saw somebody try and use this as U, which was a fine way to start. Then when you do it, you realize, I don't have, like this is there, but then the cosine wasn't there, so then we backed up, and it's really just what's in the parentheses, right? And then if I can just split it up all by addition, I can do that. I don't have to get fancy. And then here, again, both of those were denominators, but this was way more than one term, and then that could be brought to the numerator there, okay? So you kind of get the hang of what to look for when you're looking for the U's. And don't forget that you have some other processes in the meantime. Okay? We good on all that? Any questions? Okay. So we're not going to fill out the back because the back is, what did you see? What do you notice? That type of thing. And I think that you kind of talked through it as you were doing it anyway. So I think we can just move on. And here is the next. Oh, you been looking for it? Oh, it's 65. Thank you. Let's see. I'll have to give me just a second. Okay. So this will be 66. Alrighty. Alrighty, 66. Well, let me do a better color there. Okay. So in the first half of Unit 6, we said that one of the things we were interested in was the ability to find the exact signed area between the curve and the x-axis. Remember, we were doing that with triangles and rectangles and things that we knew the area formulas of. But how do we accomplish this when we are not provided a graph whose regions are not easily defined as geometric shapes? This is how we do it, okay? So let's recall the fundamental theorem of calculus. That was this. It is the integral from a to b of f of x dx. Okay, so those are the integrals that we've been doing, right? That's equal to, so when I integrate a lowercase f, it becomes a big F. F of b minus f of a. Like so. All right, does that sound familiar? Yes? Okay. So when we integrate this part here, that becomes the big F. And so when we integrate that, then we can just basically substitute those two in. That's what we're going to do right here. So if I can integrate this, right? And when I do that, when you integrate bx squared, what are you going to get? How do I integrate x squared? X cubed over 3. Okay, y'all are worrying me a little bit. Plus, when I integrate 4, what do I get? 4x. And then I have a plus c. So what we have here that we didn't have, if you still have that salmon paper handy, you can see that we didn't have this 1 and the 3. There wasn't anything there, right? Because it was an indefinite integral. This is definite. We actually have numbers that we're going to use. So then we're going to evaluate this from 1 to 3. Okay? So remember, this is our little f. We just integrated it, and now we're going to evaluate it here. That's what's happening here. So when I do this, now I'm going to take the 3 and I'm going to substitute it in here. So I'm going to get 3 cubed over 3 plus 4 times 3 plus c. Okay? That's this part, the b. And then minus, and since I'm going to have more than one term, I'm going to open my parentheses, and I'm going to substitute the 1 in there, and I'm going to have 1 cubed over 3 plus 4 times 1 plus c. Okay? Everybody with me so far? Okay, so then what is 3 cubed divided by 3? 3 cubed is 27, divided by 3 is 9. So I have 9 plus 12, yes? Plus c. You with me for those 3 things? Okay, then minus, what's 3 cubed? I'm sorry, 3 cubed. What's 1 cubed over 3? 1/3. 1/3 plus 4 plus c, right? So we've kind of simplified it all down. So 9 plus 12 is what? 21. And then minus 4, yes? Okay. What's 21 minus 4? 17. So that still gives me 17 minus 1/3. And what is c minus c? 0. And so the c's, you see how those just cancel out? And because of that, we're not going to write them in here anymore. And then 17 minus 1/3. I really didn't have to simplify it past that, but I wanted you to see how the c's were going to cancel out. Okay? We all good on that? So because the c's cancel out every time because we're subtracting, like they still have to be here because it's part of the integration, but then it's irrelevant in the rest of the actual work. Okay? We all okay with all that? All right, so let's make sure that we know the names of the parts. Vocabulary is important here. So every definite integral, so an indefinite integral, we don't have the a and the b because it could just be whatever. That's why we have that plus c there. But when we have the a and the b, it's definite, meaning I'm getting an actual integration of some specific part there. So the b and the a, I guess I'll just write them like this. Wasn't really sure how I would write them over here. The a and the b and the a. These are the limits of integration. So if we're talking about integrals and something is said about the limits, it's not the limits as we've been talking about limits before, right? These are limits of integration, or they could also be your bounds, the boundaries. The f of x is called the integrand. And the dx is called the differential. Let me spell it correctly. Differential. Right, differential. Everybody okay so far? All right. So all of these components, all 3 of these components must have the same variable. So when we use u substitution on a definite integral, like we already know to change this and this into our u's, right? We must also make sure we also change the limits of integration. And because of that, here's an AP exam tip, we do not, when we do a definite integral, we never convert our function back to x. Basically, we're leaving it in u's. So if it's an indefinite integral, we don't have the numbers there, and you have, you end up with u cubed or whatever it is that we did earlier, and you put the x's back in, right? If you have a definite integral where we're using numbers, we're not going to, and I'm going to show you why here in just a second. Okay? Questions at this point? All right, let me show you what I mean. So we are going to integrate this. Do you think this is going to require u substitution? Well, let me ask you another question, too. Could I multiply this all out like we did that other one? We could. But we could also do this one with u substitution. So since we can do that, that's a little simpler. Like the other one, we had to multiply out because it wasn't an option. But here, I can use this for u. Okay? So we're going to say that u is equal to x cubed plus 1. Therefore, du is equal to 3x squared dx. You agree with all that? All right, so that means here I'm going to have to multiply by a 3 in here and a 1/3 out there. You agree with that? So now when we integrate, okay, this becomes my u, so this is going to be u squared, and then all of that is my du, but I am not putting 1 and 2 as the numbers there. Stop it. I'm not putting 1 and 2 in here because those were x, all right? So if x is equal to 2, like this upper limit right here, if x is equal to 2, then what is u going to be? If x is 2, what is u? 9. Yeah, thank you. It's 9, yes. And when x equals 1, what is u? 2. So now since everything's in terms of u, instead of going from 1 to 2, I have to go from 2 to 9. And then everything's in terms of u. Okay? I'm saying that u is equal to x cubed plus 1. If that's true, that's why I get to put a u in here. We agree with that? So that means when here, these are referring to x's. So basically, I'm going to take the integral when x goes from 1 to 2. Well, these aren't x's anymore. They're u's. So when x is 2, when I substitute it in there, I get 9 for u. When x is 1, I get 2 for u. You with me on that? So I changed those limits of integration. That's something sometimes people forget to do. We don't want to be those people. So then when I integrate, and I'll show you, it just makes everything easier, actually. Now I'm going to integrate this. So this is going to give me u cubed over 3, right? Plus c, and I'm going to evaluate it from 2 to 9. Oh, and the 1/3 out here. Thank you. Good Lord. I left it off. Thank you. That guy's got to come down there. Boop. So then this is equal to 1, it's actually 1/9, right? If I do that 1/3 and the 3, 1/9 times 9 cubed, and then minus 1/9 times 2 cubed. Everybody okay with where all that came from? Now, do we really have to figure out what 9 cubed is? Think about that. 9 cubed divided by 9, isn't that just 9 squared? Yes? Okay. So this just gives me 81 minus 8 over 9, which I could leave exactly like this on a free response question. If I can at least get this far and it's multiple choice, I could probably figure it out from there, without having to actually do the fractions or whatever. Everybody okay on all that? What questions you got? Okay, so just adding a little piece to our u substitution. We got another one over here. What would you choose? Or do we need u substitution over here? What do you think? Yes, since this isn't plain old x, I need it for that, right? Okay, so u is equal to 3x. So u is equal to 3x. So du is equal to 3 dx. Okay. then so I don't forget, I need to do my limits here. If x is equal to pi sixths, then u is equal to what? Pi halves, good. And if x is equal to 0, u is equal to 0. We understand how we got pi halves from that? Okay. All right, good deal. So then I'm going to integrate from 0 to pi halves sine of u du. When I integrate sine, what do I get? Negative cosine. Good. Remember, you can do this. If that helps you. So this is going the derivative going down and then going up. So if I'm going up this way, I got to go all the way to negative cosine. Very good. So this is negative cosine of u plus c. And I'm going to evaluate it from 0 to pi halves. So that means I need negative cosine of pi halves minus a negative what is with the sound effects today? Minus, that's okay, negative cosine of 0. At least I know you're just like, you're not doing them to be annoying, they're just happening. You don't even know. You were doing them to be annoying? Yeah, I kind of figured somebody was. All right, what's the cosine of pi halves? What did I do? Oh my God! Yes. The humming's throwing me off. The sound is in my brain. Yes, I totally did a lot of wrong. Again, I know it's shocking. I need to multiply by 3, so I need a 1/3 out here. So I need a 1/3 out here again. 1/3. And then that's being multiplied. Yeah. So then negative 1/3 and 1/3. All right, so what is the cosine of pi halves, though? Cosine of pi halves. 0. Minus a negative, which is really plus 1/3 times cosine of 0, which is 1. The answer is 1/3. There wasn't a whole lot of resounding answers to what is the cosine of pi halves. Breaks my heart a little bit, but it's okay. We should call my mistake. So do we need to recall that real quick? Cosine, sine and cosine, which one is x? Cosine. Okay, good. So when you think of it, do you know where pi halves is? It's right here, right? 0 is right here. So this is 0, 1, and this is 1, 0. It doesn't have to be anything crazy, okay? That's what we're going for there, okay? You got this. I know it's still in there. You just got to figure out how to recall it. All right, any questions? All right, you want to take wagers on whether or not I can do this one without messing anything up? Or maybe we shouldn't. $20? You're going to make a lot of money off of me. All right, let's see. Well, why don't we see, you smart Alex, see if you can figure this one out. Yes, you can. What should we do first on this? Rewrite it. I would suggest rewriting it. If you have secant squared or tangent squared, that's different. But with sine and cosine, I would rewrite it. Even me that keeps messing up. 0 and pi 20ths. And then I would rewrite this as the sine of 5x to the third times the cosine of 5x dx. Then is it a little bit easier to maybe figure out what the u should be? I think so. Let's see what we can get done on this one. It's general. Yeah, you're good. Mm-hmm. Right, not a plus, not a plus. No, well, what are you using for you? I wouldn't use the whole. I would just use sine of 5x. You just use what's inside of that. Yeah. I think that I would use sine of 5x as my u. We at least all have that part, so we're going to get started right. Okay. Du. If we don't match, ask me a question. Pretty confident I'm right this time. Bless you. Bless you. What's your question? You did everything beautifully so far. Oh, sure it does. Because this, you see this where this 1/20th comes from? Okay, times this, that, now you're substituting this to the fourth. Yeah, this is your u. You substituted in there. Take that to the fourth power. That's why I have that square root of 2 over 2 to the fourth.
So for mine, it would just be on top of this, right?
Well, I would put it. I think that would be kind of a little bit confusing for you. I would leave it as 1 over 20, and then just put that next to it. It's the same thing. You're on the right track.
But where's, oh my God.
You're not dumb. Yeah, that's the B. That's the B part there. Yeah. Yeah, so what you're trying to do is just that right there. So you have that part, and then that's your u to the fourth. Yeah. Okay. Yes. How did I get those numbers? Because that's the 1 over 120, and then I took this to the fourth power.
Oh, okay, so this is...
That's just zeroed out. Yeah, it's just zeroed out. Yeah. Yes. You can leave it like that. I just think that it, as long as you know what to do with it, it's not wrong. It's totally fine. But then just having a fraction and a fraction, as long as you don't do weird things when you do it, you're totally fine. It's not wrong. What you have is totally fine. So I took it to the fourth power. So the square root of 2 squared is just 2, right? And then 2 squared gives me that 4. And then 2 squared is 4, and then I square it again and get 16. Okay. So basically, I just squared it and squared it again. Anything else? We good? Yeah. But notice I didn't put the sign of, that's what we put on the front. We're never going to put it back in. Since we put this back in, that's why we had to change these numbers. You see how it's, yeah, you turn them into u's. That's why we found when u is, when x is this, u is this. So we change these right here. That's what those, and so if those go there, then we leave it like this, and then we just evaluate it. Okay? That makes sense? We're good on that? Okay. Yeah, so there were some questions, very good questions about this part right here, because I wrote this, I didn't write this as 1/5 times u to the 4th over 4, which I could have. And then you could have left you could have put this part in the numerator here, and that's fine. But then you end up with a fraction and a fraction. And as long as it doesn't freak you out and you don't do anything wrong, then you're okay. The other question was about how I got from here to here. Well, when you take something to the 4th power, it's the same thing as squaring it and squaring it again. So I squared the square root of 2 and got 2, squared it again and got 4, squared 2 and got 4, squared it again and got 16, and that's where that came from. Okay. Anything else at all? All right, good deal. So let's look at E. What do we think we might use as our U? I'd use the 1 plus e to the x. I'd use what's in the denominator. So if u is equal to 1 plus e to the x, then du is equal to what? E to the x dx. Very good. Okay, so that looks like that's going to work out nicely, right? Because that's here. I don't have to remember to multiply and whatever that I kept messing up. Okay, so with that done, when x equals 0, what does u equal? If I substitute 0 in here, what's e to the 0 power? 1, and when I add those two together, I get 2. So then when x equals 1, then that's going to give me u equals 1 plus e. We agree with those? Okay. So then let's come back over here. I'm going to integrate from, and instead of from 0 to 1, I'm going from, I guess I did these kind of backwards. I'm going from 2 to 1 plus e. It doesn't really matter what order you put them in as long as you put them back in the right place over there. So I did them opposite of what I've been doing. And then this is all the du, so this gives me 1 over u du. Sure? Okay. Then when I integrate 1 over u, what does that become? Natural log. Good. So then I'm going to have the natural log of the absolute value of u plus c evaluated from 2 to 1 plus e. Everybody okay with that? So then this is going to give me the natural log of the absolute value of 1 plus e minus the natural log of the absolute value of 2. And that's it. Okay? You don't need to go any farther than that. That's it right there. E equals easy, that's right. There was a lot less actual work there, right, than there was over here when I had to do, which honestly I could have, depending on the type of question it is, I could have stopped right here. I can't stop here because I haven't evaluated yet, but once I evaluated it, that would be an acceptable answer unless I have to match it in a multiple choice. So that's what we have to remember is that, yes, we can stop, but we still have to know how to move forward in case we absolutely have to. Okay? You want to try F? Yes. The answer is yes. Yes. You want to do F all by yourself. You got this. You can do it. I would do U sub. Yes. The natural log of E is 1, yes. What did Ms. Bruce tell you about the exponents? Because I think you had come and asked me a question the other day, and I think this might have been what you were talking about. Was that you? Okay, never mind. That's not what you were asking. I'll help you out through once you see if you can see how far you can get on this. And be careful with, I know what you mean by this, but make sure you put U equals.
Oh,
Yeah, just for your work. No, you're fine. I just double checking that we. Okay. Okay, but you didn't change these. You are cheating. Don't be a cheater. Get off your phone. Yeah, which makes you a cheater. Put that down. You need to change these before you get to here and before you get to here. Like you have to, if X is equal to E, then what is U? Because these don't match. Like this is all in terms of U, but this is still in terms of X. Okay? So did we all agree that natural log of X is our U? du is 1 over X dx. And watch your notation on all of this because you are stating what you're about to substitute. And if you don't state that stuff correctly, then when you substitute, what you're doing doesn't make sense. And you're kind of lying, I guess. I don't know. All right, so then I also need to do my limits here. If X is equal to E squared, then U is equal to, so let me write this one out, the natural log of E squared, right? Now, what's the natural log of E? 1. What are my log rules that allow, what does that 2 get to do? Do we remember? From Algebra 2 and Pre-Cal? It gets to come out front as an exponent. So that's actually equal to 2 times the natural log of E. You remember that rule? It's a log rule, you gotta know. So natural log of E is 1, which means in this case that U is just 2. Okay? And then if X is equal to plain old E, then U is equal to 1. Because the natural log of E is 1. That's something that we got to know. So then when I substitute all this stuff in here, instead of going from E to E squared, I'm going from 1 to 2. Now this, like 1 over X dx, right? That's this right here. So then this is just U to the 4th du. All right? All right, then see if you can finish that up. They're like little puzzles. Should be very exciting, and you're loving it, every minute of it. Don't give me looks like that. I'm not patronizing you. You don't know what it means. Yeah, we should. 2, 4, 8, 16, 32. I want you to know where the 6 stops are, but I also want you to kind of struggle through the other stuff a little bit because you still have to be able to do that. I know. Struggle through the multiplying by 2. How are we doing on that? We good? Yes? Okay. All right. So tomorrow we're going to finish this up, and then we're going to have time just to work on stuff. Does anybody know they're not going to be here tomorrow, and I can go ahead and give you the work? Okay. What's your question? Okay.